Now let's look at question number 3. Give a complete formal proof that this particular thing. Okay, we have to give a complete formal proof to prove this. So let's start with the initial Hoare triple that's given to us. True if x is greater than or equal to y, then max equals x, else max equals y, max equals max xy. Okay, so here as we can see we need to use the rule for if. So initially we need to have P and C condition. Condition is x is greater than or equal to y. P and C S1. Then we have Q, max equals max xy. Then we have P and the negation of the condition. S2 and Q. Okay. Next. Let's simplify this a bit. So we have true and x greater than or equal to y, which means simply x is greater than or equal to y. And here we have true and negation x greater than or equal to y, which means simply x is less than y. Okay, that's done. Now we can apply the assignment rule as usual. So let's go ahead and do that. We have Q E over X, E over X. So X is max, and then we have max equals X. And then over here we have max equals max xy, E over X, max equals y, max equals max xy. Okay, now since we have this, what we can do now is we replace x with e. So let's replace x with e. Now our x is max, so let's replace max with the value for e. What we used for e was x. E is equal to x. So let's replace that. So we have x is equal to max xy, and in the fraction the denominator cancels with the numerator, so we're not gonna write it again. Max equals x and this part, And then we have over here y equals max xy, and we have max is y, and then the other part. Okay, now we have to show that, as the question says, we have to say that this proof comes from x greater than y implies max xy equals x, and this implies max xy equals y. So here, as you can see, we have performed precondition strengthening by replacing x equals max xy with x greater than or equal to y. And in the second Hoare triple, x less than y and y equals max xy. So we have x greater than or equal to y implies x equals max xy, and we also have x less than y implies y equals max xy. So we have gone from here to here using the rule for if. And then we went from here to here using the assignment rule. Okay, now let's go to question number 4. We have to prove this Hoare triple using inference rules. So we have x greater than 0 while x not equal to 0, do x equals x minus 1 true. Okay, so here, since we have a while loop, we have to use the rule for while. So let's use the rule for while. So we have P while C do S, and then we have P and negation C. P okay, then we have P and C. X equals x plus 1 minus 1. And we have P. Okay, then let's apply the assignment rule. P Q E over X x equals to e and x greater than 0. Now let's simplify this by adding e to x. So we have x minus 1 greater than 0, x equals x minus 1, x greater than 0, which means x is greater than 0, x equals x minus 1, x is greater than 0. So when you see this, you understand that this is valid because initially x is greater than 0, and when you subtract 1 from it, it will be greater than 0. So here, let's now write the precondition strengthening and postcondition weakening. So we have this strong postcondition and the weak one is true. And that's postcondition weakening. Precondition strengthening is over here. So we have this implies the weaker one. So with that, we have a formal proof for the Hoare triple which was given in the question. So that's it for this tutorial. There are some questions left for you to try. I'll see you in the next tutorial.